Hello everyone, so welcome to Thermodynamics lecture. Now I will discuss pure substance. You can see the slide here, and let me tell a little bit about why I'm going to discuss this pure substance. In thermodynamics, we have to deal with different working fluid. The one working fluid, it is steam, and the other one is the ideal gas. So this two, we said this is actually the working fluid. Okay, so to understand the properties of this working fluid, we need to understand the pure substance. So in general, pure substance is a substance which is chemically homogeneous and it has fixed chemical composition throughout the system. So let's say again, so that substance should have some chemically homogeneous and fixed composition. So it will not change throughout the system, it will be fixed. So this pure substance, it could be, it could be single phase. Okay, it could be combination of couple of single phases, or it could be kind of mixed. So that's what I said. The pure substance could be single phase, combination of various phases, or it could be mixture. Now let's say some example. If you see this figure here, actually the nitrogen and the air, this is two different gas, So nitrogen, it is, if you have a system which is filled with nitrogen, so we know the chemical composition of the nitrogen. So if you have only one gas, that means the chemical composition, it will be fixed, it will be homogeneous throughout the system. It's not changing with the time. So let's say you have different volume of nitrogen in different system, but it doesn't matter, you have the nitrogen in every system, so you're not changing the chemical composition is not changing. So that's actually, according to this definition, it is pure substance. Similarly, air, it is also pure substance because it is a single phase we're considering. So now let's say the combination of the mixture of liquid and gas. Okay, so if we consider some mixture, so in general I can say, like say, if we consider oil and the water, if we have a system like this and if we have oil and water, so what will happen? You all know actually oil, it is not soluble in water, so that means this oil, it will collect on the top of the water. So if we have this mixture, oil will be at the top and the water, it should be at the bottom. So here actually this is not chemically homogeneous because the chemical composition of oil and water is different, so we can't say this is a pure substance. So it's not a pure substance. But if we have the vapor, that means the water vapor and the liquid water, if we have this mixture, so this we said vapor, you see this is H2O, H2O means water. So this is actually the the water vapor, and this is the liquid water. We can say this is a pure substance because the chemical composition of this water vapor and the liquid water, it is actually same. It doesn't matter if you change the volume of this liquid vapor or the liquid the water, so it won't change. So that means we can say this is actually a pure substance. Now here, if we consider a mixture of gas, you see here, and liquid, so in other words, to make it simple, this gas means it is actually the dry air. You see at the bottom, it is actually air. So it will be the dry air and the liquid air. So if we consider the combination of a mixture of liquid air and the dry air, is it a pure substance? Actually, it's not a pure substance because the chemical composition of the gas and the liquid air, it's different. For liquid air, we will have a higher amount of nitrogens, so this is different than the dry air. So that means actually it is not a pure substance. So the mixture of this. So now we will discuss about the phases. In general, in our real life, if we consider water, okay, so what we know water could be liquid, we know it could be the vapor, and it could be gas, ice, okay, ice. So let's say vapor and liquid. So this is three phases you can see actually we are familiar with. This is in our real life, it is three phases. So in general, let me discuss a little bit. At room temperature and pressure, copper, if we consider copper is actually solid in room temperature. Similarly, if you consider mercury, it is liquid, nitrogen, it is gas. So this is three principal phases we can experience in our real life. The first one is solid, then liquid, then gas. More, if we discuss more examples, let's say carbon. So carbon actually in real life. So suppose we said three principal phases: solid, liquid, and gas. But in a simple phase, like in solid phase, the materials or the substance, it could be different, more phases. Like carbon could be graphite, and it could be diamond as well. And this is when carbon is solid. So in solid phase, carbon could be graphite or it could be solid. Similarly, helium, it could be two different phases. This is liquid phase. So, and in other words, ice have 7 different phases. Iron, I said, iron has 3 solid phases. So what I'm trying to say is, in a single solid phase or liquid phase, a substance could have different phases which are chemically different. So here actually the phase, in simple word, if you ask me what is phase, it is physically distinct homogeneous part of the system. Phase is physically distinct homogeneous part of system. So three principal phases: solid, liquid, and gas. Here we can say this is actually solid. This figure A, the figure B, this is actually liquid, and the third one, you see the figure C, it is actually gas. Let's discuss a little bit about this structure. And to understand this, you do not need to have some molecular knowledge, molecular structure, and the behavior knowledge. You don't need it, but if you have some, there's some plus points. So here you can see for the first figure, when it is solid, actually it is a three-dimensional structure. If you see the solid on, it is solid structure, it is very arranged, and the molecules, let's say this is one molecules, this is other molecules, so they are very close to each other. The gap between two molecules is very small, and the intermolecular force between two molecules are very strong, and this strong attraction force actually keeps or helps to develop the solid objects. And you see here this solid objects, as I said, the difference or the gap between two molecules is very small, so they usually can't move from each other. They can't move. This is the position is fixed, but what they can do, they can oscillate or they can vibrate, and this vibration actually happens due to the temperature. So the velocity of these molecules during this oscillation actually depends on temperature. So if you have sufficiently high, or the high temperature, the velocity and eventually not only the velocity, the momentum of this molecule reach a point where this intermolecular attractions, we said this is one molecule, this is another molecule, so the attraction between two intermolecular two intermolecules actually overcomes the intermolecular force, partially overcome, not fully, and they just break their bondings between each other. So they should have, I said, they have very strong bonding, strong intermolecular forces. So when we increase the temperature, this molecular bonding overcome, and they, this molecule breaks, and at sufficiently high temperature, actually, it start beginning or melting this system, and that is actually the starting of, that is just the beginning of this liquid phase. So that means this, from the solid phase to liquid phase, we need to employ higher temperature. And then the characteristics of the liquid phase is it is not that organized like the solid phase, and here the intermolecular attraction force is not that higher than the solid phases. Here, when it is the liquid phase, we will see molecules are no longer in fixed position, they are in traveling, and they can easily move to each other. So in this liquid phase, this intermolecular force becomes weak, and if we put more temperature, then this intermolecular connections completely destroy, and then it will move, it will turns to the gaseous phase, and that's actually this section C. So, and in this gaseous phase, it will be a random movement, like kind of Brownian motions. Brownian motion is some spontaneous and random movement of the gas molecules. And some important thing I actually want to tell you now, the gas phase, it has very high energy, because we need higher temperature means higher energy compared to the, so that for gas phase we have high energy compared to the solid and liquid, because we need high temperature to get these gas molecules, and at this high temperature it has high energy, and it is actually the necessary where when gas condenses or liquefies, we actually need relative amount of high energy. We'll discuss later on when we will move to the next chapter, then we'll discuss this sort of things. So in general, if I do a quick review, so what I said, I actually wanted to make this video a bit lengthy. I could finish it a bit earlier, but this is the first one, so I just tried to make it a bit longer. So I actually want to now summarize this, what I said. Pure substance is something which is chemically homogeneous, and it will have some fixed chemical composition, and it could be the summary is it could be single phase, it could be combination of various phases, or it could be mixture. And the phase, the definition of phases, it is physically distinct homogeneous part of a system, and in our real life we'll get three different phases: solid, liquid, and gas. So in the next video we'll discuss actually how this phase change process of pure substance occur and the physics behind it. So I think that's it.